Hello everybody and welcome to another SEG2900 lecture. Today is all about Git. Now again, in the past what we did is we actually let a huge chunk of this to you guys. You guys just went out and learned it yourself. You asked the TAs for help where you could, you asked me for help, you asked the professor for help, and we just kind of let you guys roam free. And the students did very well and they figured out a lot yourself. But one of the biggest pieces of feedback we got is that the students wish they had a little bit of formal lecture on this. So what we're going to do is we're going to give you kind of a brief introduction to Git, but do know that there's a lot of information here. It can be a little bit confusing. So reading up a little bit by yourself and learning a little bit more by yourself may help solidify some of these ideas. So it is a very dense lecture. There is a lot to learn. There's a lot to go through. So let's just get started. Okay, so an introduction to Git. All right, so before we do Git, do know that Git is basically a program on your computer. Okay, it's basically a program on your computer. And there are multiple ways to use Git. Sometimes you can use Git through what we call a command line interface. So for those of you who are on Windows, you might know what the command prompt is, or sometimes newly released the Windows terminal. Also Mac OS X and Linux, or Mac OS X and Linux. There's something called the terminal that some of you may be familiar with. But if you guys are not familiar with that, that's basically how we used to interact with computers. Before we had mouse dragging and windows and all this stuff, we would just interact through typing lines of code. And that's what these are. They're command line interfaces. Okay, so you would enter a command line and that would be your interface to the computer. Okay. So that is one way you can do it. There are also programs that make Git a bit more visually friendly. So where you use your mouse and right click and stuff like that and buttons. But in this course, we're going to learn the command line way to use Git. Okay, so we're going to do that. And if you're not familiar with command line, that's where we really want to start. So what we're going to talk about first is command line interfaces, specifically terminal in the Mac OS X and Linux, and Git Bash in Windows. Okay, so we're not going to use command prompt. Command prompt again is another command line interface on Windows, but we're going to use Git Bash instead. Okay, so what are these command lines? So like I said, today, when you interact with a computer, most likely you're familiar with opening up a window, say like My Computer or your home folder or something, and then you double click down to get into folders. Sometimes you'll right click to create a new folder, or you'll rename a folder, you'll copy and paste files, you'll move files, all these kind of things, right? That is a graphical user interface, okay? So it's graphic rich interface, right? So another way though you can interact with the exact same folders and files. So on your system, there's a bunch of folders and files, right? Another way you can interact with that is what's called the command line interface, okay? And like I said, in Mac OS X and Linux, you use the terminal, and in Windows, you would typically use command prompt, but for this lecture, we're gonna use Git Bash, okay? And so these are command line interfaces. And again, they're what you use to kind of navigate your files, your folders, all these kind of things, and do a lot of other stuff, okay? So here are some typical commands that you can use in your command line interface, okay? So CD stands for change directory, and then you specify the directory. So a directory is like a folder basically, right? So let's say you had 5 folders, okay? It's called like school projects, personal, photos, videos or something, right? And on a graphical user interface, you would double click that folder to go into it. Well, on the command line interface, you type CD space and then the name of the folder. So you could say CD space school projects, and then you would be inside that folder, okay? Now, on a graphical user interface, it's very easy to see what folder you're in, because usually at the top, they kind of show you where you are. Well, in the terminal, if you want to see where you are, you type PWD, and that will show you what folder you're in, basically, present working directory. You can also get a list of all the files in that directory. Like in a graphical user interface, when you double click on it, you just see all the files, right? Not so much in command line. You type ls to see a full list of files. You can make a directory with mkdir, and you can remove files using rm. Okay, like to delete files. So these are very common terminal and Git Bash commands. If you're curious for Windows command prompt or DOS, okay, they actually have a different set of commands. Okay, so cd is still the same, but to do a listing of everything in there, you type dir rather than ls, right? And instead of rm for remove, you use del for delete. Very similar. Okay, so let's just briefly take a look at this. So I'll just open up my terminal here. Okay, so here's my terminal. So I can type, pwd. I'll just make this a little bit bigger. So I can type pwd, and that shows where I am. I'll say, so currently I'm in the /users directory /Casey Lee, or another way to think of that, the users folder, the Casey Lee folder. Okay, so I can come in here and I could type cd dev, because I know that folder exists. Because again, in the last lecture we created this folder. Okay, so now I'm in the dev directory. Okay, so I can type pwd, and you'll see now I'm in /users /Casey Lee /dev. I could go even further and go into web projects. Okay. Now there's a little shortcut there if you want to be a bit of a power user. If you start typing a folder name, okay, and you have most of it, you can just hit tab and it'll auto complete it for you. Okay. So there we go. So now I'm currently sitting in users Casey Lee dev project web projects. Okay. So let's say I want to see a listing of stuff that's under there. I can type ls. Okay, so it shows me, oh, I already have this my first website folder in there, okay? So maybe I go into that, so my first website, and type ls, and you'll see it gives me all the files that are in there, the readme.txt, the contact.html, see all the files in there, okay? So it's a little bit of an older school way to deal with this stuff, but it is very efficient. It's very quick. Don't require a mouse. You just kind of type really fast, and it's really quick at doing a lot of other things as well. So this is just a different way to interact with files and folders. Okay, but this is where we're actually going to use Git. Okay, so I want to give you a brief introduction to the terminal before we use Git. Okay, so practice around with that. If you're not familiar with this, open it up. Start creating folders, navigate around folders, change folders, whatever. If you're curious, how do you go up a folder? It's cd ... Okay, and that goes up a folder. So cd space ... Okay. So I'll just go back into there, and there we go. Okay. All right, so that is the command line interface. Okay, so that has nothing to do with Git itself. That's just where we're going to be using Git. Okay, so let's talk about Git. So what is Git? Okay, so just so you know, like I said, this is a very dense lecture. There's a lot of technical stuff to learn. I highly recommend going to my series called Getting to Know You on YouTube. If you go to caseylee.com/videos and you're finding this very confusing, there are way more lectures on my YouTube channel called Getting to Know You, and they walk you through step by step how to do this. Okay, so it's a lot longer, it's a lot bigger of a time investment. Each video is quite long, and there's about 15 of them, but they really walk you through Git from front to back. Okay, so if you find this very confusing, I highly recommend you go to these videos and watch those. They'll probably help you in a lot slower way and get more detailed as to how these things work. Okay, so Git, what is Git? Okay, so let me talk about what source control is. So Git is a source control system, but what is source control? Okay, so source control comes from basically source code. Okay, so source code. So if you never programmed anything in your life, what you write is called source code. Okay, the commands and all the characters that you write to create a program is called source code. Okay. And source control is basically a way to control your source code. Okay, so why would you use that? Well, let's think about life without source control. Okay, so let's say I'm working with my friend. Okay, we'll call him Joe. Okay, so me and Joe are working on a program together. And so what I do is I start typing up some source code. Okay, so I type up a file and start typing up some source code. And then Joe wants to work on that with me. Okay, so what I do is I say, Joe, not a problem. Let me finish what I'm doing first. I'll finish what I'm doing. And then what I'll do is I'll take that file and I'll email it to him. And then he takes it over and then he starts making his changes. Okay, and then he emails it back to me. Okay, great. Thanks, Joe. Okay, then I start working on it. Okay. There are a lot of things that could go wrong there. Okay, so first of all, what if Joe changes something and I don't really know about it? Okay. So I sent him the file and I said, okay, Joe, can you work on this part? But then he realizes that there was something wrong with my code, so he changed it. And then when he sends it back to me, I don't really know what he changed, right? And then I start working on it, and then it starts getting bigger and bigger. And this is just one file. There are programs that are millions of lines of code, many, many files, hundreds of thousands of files. How can you possibly keep track of all that stuff, right? So one of the things that source control does is basically track changes. Okay, so very similar to how Microsoft Word and Excel and stuff like that tracks changes, source control basically tracks every single change that's ever been made to your source code. Okay, you start with a baseline and say, this is how my code looks now. And every single change that you ever do, you basically record a snapshot. Okay, record a snapshot, record a snapshot, record a snapshot, record a snapshot. Okay. So that's one of the great things about source control. It records everything. So you know everything that was ever done to the source code and in what order it was done and who did it and all this stuff. That's what source control does. Okay. The other thing that source control really helps with is collaboration. Okay. So when I'm working with Joe, it's very hard for me to say, okay, you work on this and then I work on this and then we email it back and forth, and like keeping in sync is really hard, because like what happens if I want to start working at the same time that he's working? So let's say I email him the file and he starts working on it and then I start working on it. And then when he's done, he emails me his stuff. And then I got to figure out, okay, well, how do I merge his stuff with my stuff? And it all gets very complicated, okay? Well, source control helps with that as well, okay? So source control is all about, one, keeping a record of all changes that you're ever made so you can keep track of everything. But two, also encourages collaboration so that you can have teams and teams of people or like big teams of people working on one single set of files, or one code base, as we might call it. Okay, that's what source control does. Okay, and there are many ways to do this. There are many source control systems out there. There's one called CVS. There's one called SVN. There's one called Mercurial or something like that. There's one called Git, which we are going to learn. And Git is one of the most popular ones, actually. Git really started to take off, I think, maybe last 15 years or so. Became very, very popular, maybe 10, I can't remember how long it's been around, but it really started to take off. And one of the biggest things about Git that's really nice is that Git is very easy to use over the internet, okay? It's very easy for me to collaborate with Joe over the internet, okay? Whereas other source control systems weren't so easy in the past to do that. They might be a little bit now. But Git is a very robust system to do this, actually. Very robust source control system. And it's a very, very popular system that so many people have adopted, okay? And that's what Git is. Git is this program to help you manage your code with other people and collaborate with other people. Okay, so it's not your program yourself. You're coding your own program, but it's something that sits on top of that to manage those files, okay? Now, we haven't even talked about GitHub yet. We'll get into GitHub a little bit later, but that's what Git is. It's a source control system, okay? Okay, so you know what Git is. It's a program to manage these files. What is a Git repository? Okay, you'll hear this word Git repository a lot. It's really a fancy word for basically a folder that Git is managing, okay? So you have a bunch of folders on your computer, right? You have this new folder that we just created called My First Website, right? So if you want Git to start managing that folder, in other words, Git starts to take notice of like when you're making changes and when you want to record changes and who you want to collaborate, okay? And so you want it to manage that folder, okay? As soon as you tell Git, I want to manage this folder and everything inside that folder, that is called a Git repository. Okay, so Git repository is really just a fancy term for a folder that's managed by Git, okay? So there's a way to basically say, okay, when you start off with all your folders on your computer, there's just all these folders everywhere, right? And you can say, okay, I want Git to manage that folder, and I want Git to manage this folder, and I want Git to manage that folder. Every single folder you tell Git to manage is what we call a Git repository. So if I told it to manage this folder and this folder and that folder, well, that's 3 Git repositories I have on my system, okay? And it's kind of interesting the way it does it, actually. It actually puts a hidden folder inside your folder. So let's say you have My First Website and you want to manage that. It actually places this invisible folder in there that you can't see called .git. You can see it if you look for it, like view invisible files and stuff like that. And it manages everything in that folder. Okay, so like all of your changes, everything that you do with Git is all inside that folder, actually. Okay, so that's what a Git repository is. It's just a folder that's managed by Git. Okay. So when you tell Git to manage that folder, it's going to start looking at everything. It's going to start managing. It's going to see any changes that you've made, all the collaboration you've made. If you ever want to get like, okay, well, what if somebody else is working on that same repository? You want to get all their changes, all this stuff. Okay, Git can do that once you've made a Git repository. Okay. Now I talked about how if I want to make this a Git repository, this Git repository, and that Git repository, I have 3 Git repositories, right? Okay, I want to mention something very important. Again, I'll wave to the camera for people who are skimming through, okay? Something that's very, very important because people make this mistake all the time when they start using Git, okay? A Git repository is a folder that Git manages, okay? So what you kind of want to think about is just like you would create a folder for every single project that you make. So let's say you build 10 websites. Well, every one of those websites should have its own folder, okay? What you probably want to do, and the most common thing you want to do, and I'm just telling you right now, this is what you should do, is every single one of those folders should be a Git repository. Not the folder on top of that. Okay, so let's say you had a folder called Web Projects, and then you have 10 folders underneath that. Well, yes, you could technically make Web Projects itself, okay, a Git repository, and then everything underneath that's managed by Git, okay? But then it gets very confusing because these are kind of unrelated projects and different people working on different things. So what's probably better is that every project that you do, you make it a Git repository, okay? And so when you tell Git, I want to manage this folder, make sure you're in the right folder, okay? And make sure you're not too high up. And in fact, the most common mistake that a lot of new students make, or people who are new to Git, is they make their like C drive a Git repository, okay? It's a very common mistake to make, okay? Some of you are probably like, oh, I can't believe people do that. It's a very common mistake to do, and it's a very easy mistake to make. So I'm just saying this right now. Do not make your top level folders Git repositories. Get down to the project folder and make that a Git repository. Okay, and I'll show you how to do that. Okay. Okay. So that's what I said. Each project should be its own Git repository. Okay. Okay. Now let's say you kind of watching this and you're like, oh my God, I actually made a top level folder a Git repository. Okay, so what do you do in that case? Like don't panic. It's not the end of the world. If that happens, it's very easy to make a Git repository back into a normal folder. Okay, so if you converted a folder into a Git repository and now you want to undo that and make that back to a normal folder, it's very simple. All you have to do is, if you're in Windows or Mac, find a way to look at hidden files or hidden folders. There's a setting to do that. Okay, and all you have to do is delete the .git folder. Okay, so if I'm in my first website, inside that folder, if I make it a Git repository, there'll be a hidden folder called .git. All you have to do is delete that and you're back to normal. Okay? Okay. All right, so Git setup. Okay. Before we jump fully into using Git, there is one thing that you guys have to do. So you installed Git in the last lecture, okay, and you type git -- version, okay, in a terminal, and you make sure that it's working. Okay, so by the way, so in the terminal here, if I type git -- version, you'll see I have a Git version running here. Okay. So once you've done that, okay, there is one setup thing that you have to do before you start using Git. And in fact, if you don't do this, it will complain to you. You have to tell Git an email address and a name for yourself. Because remember, I told you Git is source control, so it manages all the changes and it tells you who did what changes. Like Joe made this change, Casey made this change, Joe made this change, whatever. So you kind of have to let Git know what your name and email address is. Okay, just so they can record those changes. Okay, so this is the name and the email address that they're going to record the changes with. And I got to say, like there's no sense in faking this. Like you want to be honest about this, because if you're working with your teammates, we want to know, what changes were made so we can work together and we can ask who did what or whatever, right? So you want to enter your name and your email address. Okay, so how do you tell Git what your name and email address is, and then from that point on, tell it to use this name and email address forever? Okay, so this is something that you configure on your system. Okay, so what you do is you just type this command here. Okay, so you do git config -- global user.name and then your name in quotation marks. Okay, And then same thing with your email address. Git config -- global user.email and then your email address. Okay. Now you need quotation marks if there's a space, but email addresses don't have spaces, so that's why there's no quotation marks around that, but around your name, that's there. Okay. So once you do that, from that point on your system, anytime you use Git, it's going to use that name and email address. Okay, by the way, if you're ever curious about did you set it right and you want to check, you can type git config -- global user.name. Okay. So without this space after. So here you go. So if I type git config -- global user.name, there we go. So mine's set to Casey Lee. And if I set my email address there, casey.lee@gmail.com. Okay. So that way you can see to make sure that it's working properly. Okay. In fact, you can see I could change my email address here. Okay, and then if I want to bring it up again, there, it's changed to bitesite.ca now. Okay, so I'm just going to change it back here. By the way, another shortcut. In the terminal, if you're curious how I retyped the last line so quickly, just hit the up arrow. That'll go to the last command that you typed. Okay. Okay. So now you in general know what Git is, and now Git's been installed, and you've set up your configuration for your username and email. So we're basically ready to start using Git. Okay, so you know what Git is, we're all set up. Okay, so how do we use Git on a day-to-day basis? Okay, well, there's really only 4 things that you really need to think about. Okay, the first thing is initializing. And all initializing means is what I was saying before. It's converting a folder into a Git repository. So initializing is basically saying, okay, from now on, I am going to tell Git to monitor this folder. Okay, I'm going to tell Git that I want you to keep track of this folder, and if anything changes, I want to know about those changes, and I want to be able to record snapshots of my changes, and I want to be able to share this folder with other people, and so they can make changes, and I want to be able to get their changes down to my machine and synchronize everything. Okay, that's what initialization is turning a regular folder into a Git repository. Okay. After your folder has been initialized as a Git repository, after you've converted a folder into a Git repository, there's really 3 main things that happen. 1, you make changes to your files. Okay, you make changes, you code, you do whatever you want, okay? 2, you stage your changes. Okay, what staging means is you're gonna tell Git, okay, all these changes that I've made, I want to get them ready to be recorded as a snapshot. Okay, so I want to record this state of my code. Okay, now staging, I want to say, is a nice way to split up your changes a little bit. Okay, so let's say you change 10 files, but 2 of these files really have to do with one change, and 8 of these files have to do with another change. So you can just stage the 8 files and record that snapshot, and then stage the other 2 files later and record that as a snapshot. Okay. So a lot of times we stage all the changes, but you can split up your staging a little bit. Okay, so staging is basically saying what files do you actually, of all the changes that you've made, which ones do you actually want to record as a snapshot? Okay, that's what staging is. And then the last step is committing. And what committing means is you're then creating that snapshot of what's on the staging, on the stage basically. Okay, what's been staged. So when you do a commit, you as a human being are going to tell Git what you've changed. You're going to write a little comment. So maybe you said added button to the homepage, or maybe you said change the theme color to blue, or fixed bug this or whatever. Okay. So when you make a commit, you are basically recording a snapshot with a little comment, and then the cycle starts over again. You make some code changes. You stage your changes, you commit them. Make some code changes, stage those changes, and then you commit them. Okay? And that's how you use Git. Okay. So let's go through each one of these steps. Okay, so how do you initialize? How do you turn a folder into a Git repository? It's actually pretty easy. So once you have Git installed and you type git -- version, okay, all you do is you navigate into the folder that you want to go to. Okay, so cd dev, cd web projects, cd my first website. Once you're inside that folder, okay, and you can always verify this with pwd, right? So I'm pwd, okay, I can verify that I'm in the right folder. Okay, so once you're in that folder, then all you have to do is type git init. Okay, init stands for initialize. If you type git init, that will convert that folder into a Git repository. And again, for those of you who are curious how this works behind the scenes, again, all it's basically doing is creating that .git folder and putting the necessary files it needs to in there. Okay, that's how you initialize. Okay, so here's an example. You cd dev, cd web projects, cd my first website, git init, and you're good to go. Okay. At that point, that folder is now a Git repository and ready to accept your changes. Okay. So now we go into the next step, which again is the code changes, the staging, and the committing. Okay. So like I said, the best way to think of Git is you're basically recording snapshots of your code. Okay. So you make some changes, you record a snapshot. Make some changes, record a snapshot. Make some changes, record a snapshot. Okay. These snapshots, we call them commits. Every snapshot that you make is called a commit. Okay. And commits are always come along with a message. You always have to specify some kind of message to kind of briefly explain what you've done in that last change. Okay. So here's an example. Okay. So we have this example. We have my first website with all these files in here. Okay. So this is just kind of our let's say we're starting with the code the way it is. Okay. Now let's say I make some changes. Okay, I've updated the index.html, I've updated the about.html, the home, and the style.css. I've updated those files, okay? So now those 4 files have changes, okay? Git will take note of this. It'll say, hey, you've made some changes to these 4 files, okay? So now let's say we want to record those changes in a snapshot. Okay, so what we do is we take a look at the modified files. Okay, so these are the 4 modified files that we have. Okay, so if we look, going back here, these are all the files, but only those 4 are modified. Okay, so we take a look at the modified files. Okay, and let's say the snapshot that we want to record, we actually don't want to record all of them in a single snapshot. Okay, we only want to record the first 2 files. Okay. So what we want to do is we want to add the index.html and the home.html to what we call the staging area. So it's kind of like the preparation area where this is going to be part of the next commit or the next snapshot. Okay. So what we do is we move them to the staging area. And then once they're in the staging area, we create a commit. We create a snapshot. Okay. So to create, when you do a commit or create or a snapshot, you are committing everything that's in the staging area. Okay, so in this case, about and style.css were not in the staging area, so they won't be part of that snapshot. But index and home are in the staging area, so they'll be part of that snapshot. Okay, so these are the commands to do that. Okay, so you make some changes, then the files that you want to add to the staging area, you do git add and then the file name. Okay, so git add index.html, git add home.html. Okay. And then when you're ready to commit that snapshot of all the files that are in the staging area, you do git commit and then -m, which stands for message. Okay. Like you're going to pass in a message to the commit command. And then you specify a message. Okay. So that's how you do that. Okay. So make code changes, add files to the staging area, record a snapshot of whatever's in the staging area. Okay. Now I should mention, if you forget to pass the -m to the commit, you may end up in this funny state where it brings up a text editor where you can edit some text. Well, that text is a way for you to add the message. Okay. So if you ever get stuck in that area, what I recommend actually is you look up how to use VI or Vim. Okay. That you'll be stuck in this text editor called VI or Vim, and then so you'll have to learn commands for that. Okay. All right. So you initialize the repository, you make some changes to files, you stage certain changes certain changes, and then you commit the message. Sorry, you commit the changes. Okay, so this is the typical workflow. Make changes to files. There's one thing I didn't mention, sorry. Step 2, git status. Git status will tell you where all these files are. Are there certain files that are changed but not staged? Are there certain files that are staged? What status are we in? Okay, so git status should become your new friend because git status won't hurt anything. Okay, git status just tells you what the scenario of everything. Okay, so just be sure that you use git status as much as you can actually. Then you do git add files. Okay, and in fact you can do git status after that to check on if the files got staged properly, and then you do a git commit -m with a message. Okay, all right. One thing I want to mention is that very, very, very typically, we actually want to stage all the changes that we've made. Okay, so it's very common that you work on a couple files and you want all those changes to be part of the commit. Okay, because that makes sense, right? Like you're doing very incremental commits, okay? And by the way, more commits is not a bad thing. If you want to commit on every single file that you change, that's not a bad thing. Like small little commits are actually really good, okay? You shouldn't feel bad about making a lot of commits. So it's very common that you change a couple files, and it's very common that you want all those files to be part of the staging area, okay? So in my example, I only picked 2 of them, but it's very common that you want all 4 of them to be there, okay? So just as a little hint, there's a little hint at the bottom of the slide here. If you want to just add all the files that have been modified to the staging area, you can do git add dot. Okay, and that'll add everything that's been changed to the staging area, ready for the commit. Okay, and that's actually the more common way to do things, actually. I see that a lot more often than individual files. I like to personally do individual files when I've done too many changes at once without doing a commit. Like sometimes I've done like so many changes, and I was like, oh wait, you know what? These 3 files really belong to changing this functionality, and these 10 files belong to this staging. So that's the only time I kind of do individual ones. But most of the time I'm doing git add dot actually. Okay, let's do a brief demo of this. Okay, so here I have my first website. Okay, and actually I have Visual Studio Code open as well. So here is my first website. I've opened the folder, and this is all the text that's in those files. Okay. Now, again, at any point after you've done git init, you should try to do git status, okay? Now, if I do git status right now, actually you'll see what happens. It'll actually complain that it's not a Git repository. Okay? I typed in git status, it says fatal. The folder that you're currently in is not a Git repository. That's right, because we haven't initialized it yet, right? Okay, so the very first step we want to do is do git init. Okay, there we go. Now it is a Git repository. So now if I type git status, actually it'll show me all this stuff. Okay. So I'm actually in the very first state now of git status, which we've initialized the folder and we told it it's a repository. So now it's starting to track files. And this is what it says. Well, it says none of these files are tracked yet. Well, that's because we're just starting. And we haven't told Git about all these files yet. We just know that this is the folder we want to monitor. So what about all these files that we have in here? Okay. Well, if you want your files to be tracked by Git, okay, you have to add them to the staging area for the first time and do a commit. Okay. So what I'm going to do is I have all these new files in here that Git doesn't know about, even though this is a Git repository now. And what I'm going to do is I'm going to add them all to the staging area. Okay. So I can either add them one by one by doing git add and then, the name of the file. Okay. So why don't we do the first 2 manually? So git add readme and then git add about. Okay. So now if I do a git status, you'll see 2 of these are in the staging area. Okay, so you say you can unstage them if you want. Okay, so 2 of these are ready to be in the snapshot. Okay, but I want all of the files to be in the snapshot. Okay, so rather than typing git add for each file, I can just do a simple git add dot. Now all of them are in the staging area. Okay, so if I do a git status now, okay, you'll see all these files are ready to be committed. They're all in the staging area, ready to be committed. Okay. So because this is my first commit, I haven't really done any changes. This is kind of the starting point, the baseline. A lot of times what people will do in this part is they'll do a commit. Okay, so commit. Now remember, commit will record a snapshot of everything that is sitting in the staging area. So all these files will be commit as part of this snapshot. -m means I'm going to pass in my message. Okay, so I'm going to put in a message here with double quotation marks. And I'm just going to call it initial commit. Okay, and that's just because this is the baseline. This is where we're starting. Okay, and there we go. So now it's committed all that. So now if I do a status, you'll see it's all clean, which means everything's been recorded. There are no changes since the last commit. Everything's recorded, everything's clean, we're all good. Okay, so this is our starting point. Okay, so that's how you start. That's how you initialize a Git repository and add your files to be tracked initially. Okay, now from this point on, any changes that you make, any new files that you add, any files that you delete, any files that you change, Git will notice it. It'll compare it to the last commit snapshot, to that last snapshot. What has changed since that last snapshot? So let's experiment with that. Okay, so let's go to Visual Studio Code. Okay, so let's say in the let's say in the home page, let's put a welcome message in here. Okay, so I'm gonna put some HTML code here. Now you don't have to put real HTML code. You can just type anything random if you want, but I'm gonna put some real HTML code here. Okay, and I'm gonna say welcome to my website. Okay. And you know what? I'm also going to add some CSS as well. Okay. So in the CSS, I'm going to add some code in here. And again, you don't have to understand this. You could just type in random characters if you want, or you can follow along exactly what I'm typing. Okay. So I'm going to say the font is going to be Arial. Okay. So I've made changes. Okay. So I've saved those two. Okay. So I've done, the shortcut, but you can say file, save, okay? So the home and style saved, okay? So now I've made some changes that Git will notice, okay? It'll notice that since the last time you recorded a snapshot, I noticed some changes, okay? So if we come here now, and we do git status, you'll see, it says, home.html has been modified and style.css has been modified. Okay. Now it's out of the scope of this lecture, but you can actually figure out what those exact differences are. Okay. But for now, we'll leave it like that, and those are modified. Okay. So now I want to record a snapshot of my changes. Okay. So what I'll do is I'll do git add dot, because I want both of them to be part of this commit. Okay. I'll just do a status to double check that they're staged now. Yep, they're staged. Okay. You can see here to unstage them, so that means they must be staged. And then I will record the snapshot. Okay, added welcome message and changed font. Okay, and now they're recorded and we're good to go. Okay, so that's how you deal with Git. You make code changes, you stage them, and you commit them. And what I recommend is, again, do this frequently. Get in the habit of like every kind of little change that you make, record a snapshot, record a snapshot, record a snapshot. Okay. If for some reason the changes aren't showing up in Git, you might have forgotten to save the file. I do have to save the file for Git to notice the change. Okay. So don't forget to do that. Okay. Now, if you're curious, yes, Visual Studio Code does have some plugins and nice visualizations of all this stuff. So you can learn there, but I do recommend trying it on the command line, so you kind of understand some of the basics there before you kind of move on to something more visual. Okay. So that is a brief demo of Git. You should practice it with your own folder, and don't be hesitant to make lots and lots of commits. Okay. So we talked about how to use Git on a day-to-day basis. But one thing we talked about Git being is we talked about being a source control, and it does two major things. One, it helps you record and track all your changes to your source code. And so we see how it did that, right? We were able to see the changes and recording each one of those snapshots. And I didn't get into it, but there is a way to go back and see all the changes that were ever made to a file and all the differences and everything like that, okay? But there's this other piece that we talked about that it's really good at helping with collaboration, working with other people. Okay. So how does Git do that? Well, that's where the idea of Git remote repositories comes into play. Okay. So let's talk about Git remote repositories. Okay. So after you play with Git for a long time and you're kind of coding away on your computer and you're recording snapshots, you're going to build up a huge number of snapshots. Okay, or a huge number of commits, and they're all on your machine. Okay, when you're recording snapshots, they're all on your machine. They haven't gone out anywhere. Okay, they're just on your machine. And actually, this is one of the things that separates Git from things like SVN and CVS. This is what's called a distributed source control system, and in the sense that everybody who uses Git, they have all their snapshots on their machine itself. Okay. So now that you have all these snapshots and all the code on your machine, how do you start to share it with your teammates and people that you want to work with so you can collaborate? Okay. So what you can do is you can copy your entire Git repository, okay, to what's called a Git remote repository. Okay. So we talked about your Git repository is a folder that's managed by Git. Well, another way to look at a Git repository is it's a folder that's managed by Git. So it means it's a folder with all your files, all your source code, all the files that are sitting there. But also it contains all the information about all the snapshots, all the differences, all the commits that were ever made, who made the commits, when they made the commits, all that information. So all the files and all this extra information, you could almost call it like Git meta information, okay? So all this extra information about the changes, who made the changes, when they made the changes, all this stuff, all that is the Git repository. And you can copy all that information, all the files and all that extra information to what's called a Git remote repository, okay? So you can copy that to another place, basically, okay? And remote repositories are basically just Git repositories that you synchronize with. Okay, so you can copy all your changes to that Git repository, and as you make changes, you can continually synchronize to that remote repository. Make some changes, commit them, and then you have like 10 new commits. Okay, well, synchronize those 10 commits with the remote repository. Okay, and you keep synchronizing to that remote repository. And every time you synchronize with that remote repository, both repositories have the exact same information. Okay? And this is actually what makes Git very powerful, because if you synchronize your entire Git repository with a remote repository, well, if your computer goes down, that repository still exists, and it exists with all the information. Not just a copy of the latest code, but the copy of the latest code and all the history of all the past code, all the changes ever. Okay? So the thing to know is that remote repositories have all the information that your repository has. So your local folder with all that information exists on a remote repository. That's what a remote repository is. A Git remote repository is something that you synchronize with all that information. Okay? All the code, all the snapshots, all the commits, all the information, all the people, all that stuff, okay? Now, remote repositories can actually be anywhere. They can actually be on your own machine, which seems a little bit confusing, but it's true, it could be. They could be on a local network. You could have one machine connected to a router and another machine connected to a router, and you could go through there. But usually, in today's day and age, those remote repositories are hosted out in the internet. Okay? So your computer could synchronize to a Git repository that's sitting on your friend's computer over the internet. Or it could synchronize with a Git repository that's sitting on a virtual server somewhere. Or it could synchronize with any number of machines. It could just synchronize any computer that's out on the internet. Okay? As long as it's set up properly, you can synchronize that. Okay? So here's an example. Here's what it looks like. Okay, so on your computer, you're doing this cycle, right? You're making changes, you're staging those changes, you're committing those changes. Making some more changes, staging those changes, committing them, and so on, okay? Over time, you build up a list of commits, right? You're gonna have commit 1, 2, 3, 4, 5. You're gonna have a lot of commits, and you should have a lot of commits, okay? So at some point, you're going to synchronize this with a Git remote. Okay? So you have this remote repository sitting out there on the internet in some computer that you've configured. Okay? Or it's your friend's computer or whatever. And you're going to synchronize these changes back and forth. So when you synchronize the change, the remote repository is going to have all those commits and all those files. Okay? Every file that's ever been part of the repository, even if you deleted it, whatever, it's all going to be there. Okay? Your entire history is going to be on your machine and the remote repository. Okay? What's interesting is there's actually no limit to how many remote repositories you synchronize to. Let's say it's just you working on it and you want to back up to one server and then you want to back up to another and another and another. You can actually have a lot of remote repositories if you want to. Okay? So you have your local Git repository on your machine, which is a folder that's managed by Git. And you could decide to synchronize it to a lot of different repositories. Okay? I've labeled them all 1 here. I don't know. That doesn't make sense. It's 1, 2, and 3. Okay, so 3 separate Git repositories, remote repositories you can synchronize to. Okay. Now, when we talk about remote and local repositories, that's really relative to who you're speaking to. So let's say me and Joe are working with each other, and let's say my Git repository is synchronizing with his Git his Git repository. Well, to me, my folder is the local repository and Joe's is the remote repository. If you're talking to Joe, obviously the one that's sitting on his computer is the local one and mine is the remote one. Okay? The repositories themselves that sit on these computers, they're just regular Git repositories. They're folders with files and the management data on there. Okay? The important thing here to know is that Git is set up that you can synchronize all this information between one repository and another repository sitting out somewhere else. Okay? Okay. Now, let's say I decide to synchronize with Joe. Okay? So let's say, I'm working with Joe and we're synchronizing back and forth. And I'm saying, okay, hey, Joe, I'm going to synchronize all my information to you and you synchronize all your information to me. And the nice thing about Git is it's pretty smart at figuring those things out, actually. And then let's say Jane, we get a new person who joins our team, and so Jane comes in with her computer, and we start synchronizing with Jane. But now it starts to get a little bit confusing, because like, okay, well, what if I'm synchronizing with Joe? Oh, I forgot to synchronize with Jane. And then Jane's like, oh, Joe, can you give me Casey's latest changes? And then, okay, so she synchronizes with Joe, and then, oh, wait, I didn't get Jane's latest changes. And then it gets a little bit confusing who we're synchronizing with and how we synchronize with or whatever, right? So you think about, that's only 3 people. What if you had like 10 people and you're trying to synchronize all these different changes between all these different people? It gets really complicated, right? So what teams do is they agree that, okay, well, rather than us all synchronizing between each other, why don't we have one Git repository in the middle of all of us? Okay, we'll set up a Git repository in the middle of all of us. And what we'll do is we'll just synchronize between that middle repository. So if Joe uploads his changes to that central repository and then Jane uploads hers, well, then I can just synchronize with that middle one to get all of theirs, right? And then I can push mine up to there and they can get theirs from that. So if we all agree upon the central place, for our code, it'd be a lot easier no matter how big the team gets. We say, okay, you know what? This Git remote repository, we're just going to agree upon informally that that's going to be our central repository. Okay? So it looks something like this. Okay, so I have a Git remote, and maybe I back up to Git remote, these other 2 Git remotes, but then there's this Git remote repo 3 that we've kind of agreed upon that, okay, yes, even though I back up to these other places, this is really the central place that we're going to agree between my teammates. Okay? So we'll just kind of gray out the backups for now, but the central place is where we agree that this is all going to come together. Okay, so because we've agreed upon this, then all my teammates agree that they're going to synchronize with that central repository as well. Okay, so this is what it looks like. Even though you can synchronize with other repositories, you formally agree upon everybody that this is where all our synchronization is going to happen. So if we want the latest code, that's where we synchronize to. Okay? That is the problem that GitHub solves. Okay, let's go back, because if we want to do this, well, maybe one of us would have to buy an extra computer, because that computer needs to be on all the time, right? Okay, so well, why don't we buy a virtual server out on the internet? Okay, yeah, that sounds good. And then when we do that, okay, well, maybe we need somebody to administer it, make sure it's up all the time, and make sure it has the proper Git settings and all this stuff, okay? Well, that is what GitHub is. GitHub is a service that allows you to host central Git repositories, okay? So you can basically set up your Git remote anywhere you want. There's a lot of services that do it, but we're going to use a service called GitHub, and that's what GitHub is. GitHub is a place to host central repositories, okay? So this was the infrastructure that we had. That is hosted on GitHub. Okay, that central repository is hosted on GitHub. So you're going to have a copy of the repository on your machine. All your teammates are going to have a copy of the repositories on their machines. And then you're going to have a copy of your repository on GitHub. And everybody's going to synchronize to that central GitHub repository. Okay? Just like how you would have a separate folder for each project, and just like you would have a separate Git repo for every project, okay? You're going to have a separate GitHub repo for every project, okay? So in this class, you're only working on one project, but after this class, you're going to have many, many projects. So when you have many, many projects, each one of them is going to be a Git repo on your local machine. Well, then each one of those is going to have a corresponding remote central Git repo on GitHub. Okay, so this is what you end up with long term. As your software development career matures, every folder on your computer that you're working on that you want to keep track of is going to be a local Git repo, and it's going to synchronize to a repo on GitHub. Okay. And there's all these instructions about how you set up a repo on GitHub, and then how you end up synchronizing your local one to the one over there. Okay? All right. So hopefully you understand what Git remote repositories are in general. So they're just another Git repository that's out there on the internet that you can synchronize with. Now, hopefully you know that what GitHub is an agreed upon central place to put that repository. Okay? So I'm going to run you briefly through how you set this up. Okay, and again, I recommend you look at my other videos for a more detailed explanation, but here's briefly how you set things up with GitHub. Okay, so if you are the one who started the project, okay, so in this class, one of you is going to be the person to start the project. You're going to create a folder on your machine, you're going to add a file to it, you're going to initialize it with Git in it, you're going to do a git add dot, and you're going to do a git commit, okay? And so you have a local repo that's sitting on your machine, okay? So one of you is going to be this person who's going to start the project. You're going to start it and just put one dummy file in there, maybe the readme.txt. You're going to put one file in there, okay? What you're going to do is you are going to go onto GitHub and you're going to create a new repository, okay? And so there's a button literally on GitHub called Create New Repository. And once you've created that, you'll be able to hook up your local repository to that remote repository. Okay, so here's how that works. So you create the local repository, then you create the remote repository on GitHub, like you literally log into github.com and you say create repository. And so that remote repository is sitting out there on the internet. So what you need to do is you need to tell your local repository where that's sitting. So the way you do that is you type in git add remote, give it a name, and specify the address. Okay, so the address will show up on github.com. And in fact, when you create a new repository on github.com, it'll actually show you these instructions. Okay, what git add remote means, a remote is a remote repository. Okay, so this is the command to add a remote repository. And really it's just a pointer. It's just like a pointer to where this thing is. Okay, so as an example, I would do git add remote origin. Origin is usually what we say as the central repository. Okay, and then specify the address. Once you've done that, you now have a pointer to that remote repository. Okay, and the very first thing you're going to do to synchronize with that remote repository is git push origin master. Okay, that will basically synchronize your code with the remote repository. Okay, that's if you're the first person to create the project. Well, what happens if you're the person who wants to join that project? Okay, so that first person has pushed their code up to the GitHub repository. So how do you now, if you're a teammate, how do you download that and synchronize to your computer? Okay, well, what you do is you do git clone and then the address. Okay, so the same address that was back here, okay, that the person pushed up, you are going to do git clone. And what that will do is it'll download all the code and all the Git information, and it'll even set up the address pointer so that you're ready to go after that. Okay. So that is how you get set up. If you're starting the project, you're going to push to a GitHub repository. If you're just joining a project, you're going to clone that. Okay. So now that you're all set up, okay, how do you work with this day to day? You're going to do things like pushing. Okay. So what push does is any changes, any commits that you've done now you want to synchronize upwards, you do a git push. Okay. Git push origin master. And then anytime you want to grab the latest changes from the repository, you do a git pull. Okay, so you type in git pull and it'll pull the latest changes down from from the remote repository down into your code. Okay. So here's an example. So anytime you're making changes, pushes up to the central repository, pulls them down. Okay. Now, one thing I kind of rushed through git push and git pull and remote repositories. Again, I highly recommend you watch the Getting to Know You videos. It can be a very complex topic, so definitely check those out for more details. Okay. Now you understand Git a little bit. You understand GitHub and remote repositories. Let me briefly talk about this course specifically and how you organize your repositories. It becomes very important, actually. So for this course specifically, you're gonna have to set up a GitHub organization. So you want to look up how to set up GitHub organizations. GitHub organizations is an easy way to add people, and then all those people have access to the repository. So remember, I said like your first teammate's going to push to the remote repository, and your other teammates are going to pull down. Well, they can only pull down if they have access to that repository. So an easy way to deal with this is by creating a GitHub organization, and you add all your user accounts to that organization, and then everybody has access to those repositories. And then what you want to do is you want to set up the repository underneath that organization rather than under your user account. Typically, when you create a repository in GitHub, it's going to create it under your user account. You want to create it under the organization that you're a part of. Now, it's very important that you name your repository a very special way for this course. This is not in general. This is just for this course. You want to go to pages.github.com and you want to look up their instructions on how you name your organization and how you name your repository. This becomes very important because if you do this correctly, it'll basically set up a website for you, which is really nice. Okay, so it's very important in this course that you're using GitHub organizations, and you're going to set up your organization name and your repository name using the instructions on pages.github.com. Okay. All right. Lots of information to take in there. Lots to do. How do I recommend that you guys actually go forward now? How do you proceed from here? Okay. First, practice by yourself, okay? Once you have Git installed, you can always do your changes and staging and commit over and over on your own folder. Just practice yourself, okay? Just doing it yourself locally on your machine. And then you can create a Git remote repository yourself that's not involved with your team. This can be just your own Git remote repository that you're pushing and pulling from, okay? You can just practice by yourself, okay? So you can do some personal practice by setting up your repository on your local machine, and then setting up a personal remote repository, and then practice pushing, okay? do a bunch of commits and push them. Do a bunch of commits and then push them. Once you do that, okay, you can then move on to setting up your team repository with your organization. Okay. So like I said, you're going to have a starting person who's going to, push to the GitHub repo, and everybody's going to clone from there. Okay. And then after that, you can then do push and pull from there. Okay. Now, one last thing to note about GitHub before we go on is that I want you guys to know that GitHub by default is public, okay? So what that means is that any code that you put up there is public. People can find it, people can search it, people can view it and see all of it, okay? So the default privacy settings for this are public. And in fact, for this course, we actually we kind of want you to keep it public so that's easy for the TAs and the professor to go in and see the code and mark your code and all that stuff, okay? So with that being said, there's two things to keep in mind. One, for this course, be very careful about what you put in your code, okay? If it's something sensitive, you know, passwords, personal information, that kind of stuff, just don't put it in there, basically. Okay, so don't put sensitive information in your code. The second thing is as you go forward beyond this course, okay, and as you start to use GitHub, do know that by default, repositories are public. So if you are committing something sensitive or something that you want to protect, make sure you use private repositories, okay? It's just a setting, and they're free now, so anybody can do it. But just know that fact, because if you're new to GitHub, you might be tempted to put everything up on there, and do know that it's public and anybody can find it. Okay. All right, like I said, if this lecture was way too confusing for you, check out the videos at caseylee.com/videos. They link to my YouTube channel, where I have a whole series on Git that I think walks you through a lot slower and in a lot more detail, and in fact covers a lot more that we covered here. So, okay, as I said, the course document is online, sample solutions on there for anything. As a reminder, mandatory DGDs, definitely check those out. Okay, and as I said, all this stuff is on caseylee.com/UO. All right, there's my contact information if you ever need to get a hold of me. And like I said, professor and TAs are always the authority. Okay, thanks so much, guys. That's it for this lecture. We'll see you guys in the next video.